Friends, my name is Nived Krishnan. I am from Conservation Technologies and I am here to teach you about the basics of electricity. Okay, now coming to the next slide. First, we need to study what is electricity. Electricity is basically a type of energy. Energy is present in our universe in different forms. For example, as you take the case of mechanical energy. Mechanical energy is a type of energy. Atomic energy is a form of energy. Heat energy is a form of energy. Like that, electrical energy is also a form of energy. Then there is a principle that is we cannot generate electricity from ourselves. We can only convert one form of energy into another form. That is, we can convert this heat energy into electrical energy, or this back heat energy to atomic energy or mechanical energy, like that. Only conversion from one form of energy to another form of energy is only possible. We cannot generate energy as our own. Okay, then for take an example. Okay, we are heating water with the help of an oil. Say with the help of a kerosene, we are heating the water, and this water, when it get heated, its energy transfer take place, and the water becomes steams. And this steam, we pass this steam into the turbine, and this when the turbine rotates, we get mechanical energy, and this mechanical energy is given to the generator. As generator rotate, we get electrical energy. Like that, energy can be converted from one form to another form. It's an example. Okay, now coming to about what is a matter. Okay, all the materials in our universe are made up of matters. These matters consist of molecules. Inside this matter comes this molecule, and inside every molecules are made up of atoms. This is a figure of an atom, for example. Okay, atoms has three things, that is protons, neutrons, and electrons. Electrons are having negative charge. Electrons are rotating like this. Here, this is an electron. Electrons are rotating around this. Okay, then what is a proton? Protons have a positive charge. Protons are present in the center. That is known, and this center is known as nucleus. Okay, and this nucleus has also these neutrons. Neutrons have no charge. So that nucleus has two items, that is protons and neutrons. Protons have positive charge. Neutrons have no charge, and these electrons are revolving around the nucleus. Electrons has negative charge. Okay, then coming to what are the factors which determine whether an atom is good or bad conductor. These are the factors you need to know. First factor is the number of electrons in the outer orbit. How many electrons are revolving in the outer orbit? Second is one is the distance of the outer orbit from the nucleus. Third one is the density of atoms within the element. That means in an element, how many atoms are present. These three points determine the conductivity of an element. Okay. Then there are some rules that you need to know. Okay. First rule is that if atom has only one orbit, that means only one round around the nucleus. In that case, number of electrons rotating around this orbit will be 2. If it has more than one orbit, then we have 8 electrons rotating. Then coming, for example, gold, silver, copper, they have only one electron rotating around their outer orbit. Okay. Now coming, what is electricity? Before coming to this electricity part, we need to know that opposite charges will always attract each other, and this same charges means, that means like charges always repel each other. Okay, then how this what is electricity means? Electricity is basically flow of these electrons. As I told, what is an electron now? Flow of electrons is considered as electricity. Okay, you need to know about the unit of electric charge. Electric unit of electric charge is coulomb. Okay, in this one coulomb, it has 6.25 into 10 raised to 18 electrons. these much electrons consist of 1 coulomb that you want to know. Okay, now coming this, you can see that in this example, this switch is open, so that here no current is passing. Okay, so on the next example, we can see that now the switch is on and the electricity passes through the circuit. What happened here is when the current start flowing through this, what will happen? Electrons will move in the opposite direction. That you need to know. Electrons always moves in the opposite direction of the current. Okay, now coming, we need to we can generate this electricity in different methods. In our batteries and all, we are storing this energy in the form of chemical energy. Okay, so if we need to generate large amount of energy, we are using the dams, and we get solar energy, and otherwise we can wind energy. These are different methods of generation of energy. Now, what is current? As I already told, the current is a flow of electrons. Okay, and as I also already told that this flow of current is opposite to that of flow of electrons. So always this current flows from high voltage to low voltage. I will say more about voltage in the next slide. Okay, then you need to know the unit of current. Unit of current is ampere, and this current is measured by a device known as ammeter that you need to know. Now, what is voltage? I would say before telling about the voltage, I will say about what is a potential. Potential is known as ability to work. And what is voltage? Voltage is the potential difference. That means the work done moving a unit positive charge from one point to that is point lower from a point having lower potential to a point at a higher potential. That work done is the potential difference. That is known as this voltage. And you need to know what is a unit of voltage. Unit of voltage is volt and is measured by voltmeter. In the case of current, we have ammeter. In case of voltage, we have voltmeter. And the what is the sources of the voltage? Source of voltage are batteries, DC generators, alternators, etc. Okay, then coming to next, this is a diagram. Always, in order to have a current flow, we need to provide a voltage. This voltage can be applied with the help of a battery. Okay, that you need to know. Now coming, there are two types of power: DC power and AC power. DC stands for direct current. AC is alternating current. DC power is present in the batteries, whereas AC power comes through the power lines in our homes. Okay. Then most of the cases for our robotic applications and all, we use DC power. But we in our homes we plug in the components. In that case, we use AC power. Okay. The power equation of a DC power is this I into R into I. That you need to know. I square R is known as power. Power equation is I square R. Okay. Then we know the unit of the power is in horsepower, and 1 horsepower is 0.746 kilowatt. And this power, how to measure this power? Power can be measured by wattmeter. That you need to remember. Then coming to AC power. As I told, AC power is the alternating current. That means this current varies alternatively. Okay. Then coming to we use this AC. Mostly we use AC currents in our homes and offices, etc. Then, as I already told, unit is power. Unit of power is watt and is measured by wattmeter. Here, in case of AC power, equation is VI cos theta. That you need to remember. That's it. Then coming to terms. Okay, as I already told, this current is represented by I, and as I already told, the unit is ampere, symbol is A, and it can be measured by ammeter. Then voltage E or V, it can be represented by E or V, and it is a unit is volt, symbol is V, and this measuring device is voltmeter. In case of resistor will be dealing in the next case. A resistor, this unit, just to remember that is ohm is the symbol unit and is measured by ohm meter. And power, as I already told, power it is denoted by P. It is its symbol. Its unit is watt and symbol is W and is measured by the watt meter. Okay. Thank you. I hope you understand this. Okay. Now we can go to practical sessions. Okay. Second, I will share my screen. Okay. Yeah. Okay. On the for practical sessions, we are using a website known as Tinkercad. Tinkercad is a website and it's a free website. Everybody can take an account in this Tinkercad. Just Google Tinkercad slash circuits and you will get a page. There are variety of exercises available here. Now today, this is as it is a first class. We shall see basic exercise, basic example, and how to blink an LED. Okay. Then as I told, the voltage source is battery. I told in the class. Okay. Then there are different type of batteries. I will show you some of the batteries. This is a 9-volt battery. This is a type of battery. This is another type of battery, that is coin cell battery. It has output voltage is 3 volt. And this is another one is 1.5 volt battery. These batteries are used in our remotes. Okay. Then this battery has higher voltage. That means it can provide large amount of current. Okay. This has 3 volt, comparatively lesser. And this small applications for us blinking of LED, we use this battery, this type of 1.5 volt battery. Now I am removing these batteries. Okay. Now how to bring an LED? Okay. Place it here. Now I am taking, I would say, number of batteries as 2 batteries. I am taking 2 batteries. Okay. Now I will take this LED. Okay. Yeah. This is LED. I place it here. Yeah. Now we need to connect by using wires. Here, look here. Here positive. This is a positive of the battery. I am connecting it to the anode. Anode is the positive of the LED. I connected that. Now cathode. Cathode is a negative of the LED, and I connecting to the negative of the battery. Okay. Yes. After connecting this, I am clicking on the start simulation. Okay. Yeah, we can see that this our LED has been destroyed, it has been broken because large amount of current is passing through this. So we cannot use this. So we are reducing the number of batteries to say 1 battery. Okay, we need only 1 battery. Now let us check. Okay, we have give start simulation. Okay, start in case of start simulation, we can see that if while giving this, yeah, our LED is blinking. Okay, yeah, when I stop simulation, it is gone. When I start simulation, it is blinking. Okay, now for safety purpose, we are using a resistor. What is the purpose of resistor is resistor limit, or it control the amount of current going into our LED, so that large amount of current will not go into the LED. So for our safety purpose, we are connecting a resistor here. Okay, I'll place it here. Okay, I remove this wire. Okay, we should connect this resistor to the positive, that you need to remember. Positive of the battery to the resistor, and another leg of this terminal 2 of the resistor to the anode. Okay, that's as you see. Now I am clicking the start simulation. As previous case, here look that the glowing is reduced. Why this glowing is reduced is because the amount of current has reduced. Okay, for example, this resistance value we can change. I change it to say 1 ohm. In default, it has 1 kilo ohm. I change to 1 ohm. Now I am giving start simulation. Yeah, we can see that the glowing has increased because resistance has been decreased. Okay. Now another, we can add another one more component, and that component is a switch. Okay, we can add a switch. Yeah, this is a known as a slide switch. Okay, we all have switches in our homes. Okay, for example, so that I am connecting this switch. Okay, I am removing this. We need not to change our resistor uh, circuit. Okay, now negative, I am connecting it to the common of the our slide switch. From the terminal 2, I am connecting to the cathode or positive. okay, cathode or negative, okay, of the LED. Okay, now we need to start simulation. When we start simulation, our this LED is on glowing. Now let us switch on. Now our switch is on. Now our LED is blinking. And when you switch it off, yeah, it is off. And when it is on, yeah, our LED is on. This is a basic exercise. You know, this is a starting of our session. So then I want you to take an account in this Tinkercad, and you need to practice. Okay, you can practice using different type of batteries, and you can change the amount of resistance. You can use different type of switches, and you should try it. Okay, I hope. Hello children, today we are doing another exercise using another exercise of blinking an LED using a breadboard. First, I will show you what is a breadboard. For getting the breadboard, yes, you can see here, here is this known as breadboard smart. There are different type of breadboards. Look here, this is a type of breadboard, that is breadboard smart. First of all, you for doing a circuit on breadboard, you need to know the how this breadboard is aligned. So that here you can see here, this is a positive, this is negative. In this breadboard, we can see that if we give a negative connection to any one of these points, then this negative is connected internally through a same wire, so that we can take negative from any one of the points from here. Okay, next here is positive. From a battery, if we give a positive to say this point, then we can take positive from here to any other components placed on this side. Okay, then coming to this side, here the connection is only in this direction. So that here here it is 30. In 30, these 5 lines have same connection, same wire, and it will not have connection with this 29th this line. So that here each horizontally, each components can be made different. Okay, circuits, these wires are not do not have any connections in between them. Okay, this is a basic thing you want to know. Then if we need to do blink an LED, we need a power source. Yeah, now last case we use a 1.5 volt battery. Now let us use a 9 volt battery. I'm placing this 9 volt battery here. In order to align this battery, we click here, and then we go to here. There is an icon for rotating. Okay, now we are rotating half. Yeah, one more, and yes, now it is rotated. We will place it here. Now we need to make a connection. Now to make connection, we this is the negative part. I am placing it here. Then from here to this place, yeah, then we can place this negative to any one point in the negative of this part. Yeah, I am placing it here. Any one point in this line, we can place it anywhere. Okay, now positive. I am taking this positive here, and I am what I'm doing is once again I am closing it here, and I am connecting it to a positive of here. Yeah, from this point. Okay, so in order to understand, here the color is green, but we it will cause confusion. So we can change this color. We need to always give this what we can say positive as a red color. We can change this color. Okay, in order to change this color, we need, here is an icon. As you can see, we can give that as red. This color as we can give as red. Okay, now it is red, and this negative part we can give as black. I'm selecting this and giving it as black. Yeah, now there is no confusion. Okay, now we need to connect an LED. For connecting a LED, we are taking a searching LED. We can either search LED or LED is present in the front itself. So we are bringing this LED here, and we are changing the orientation. First, let us place it somewhere here. Okay, we are changing the orientation. We are rotating it. Okay, right? Yeah. Once again, one more time, we can do it. Yeah. Now it is like this. We are placing it, somewhere here. Yeah. we are placing it here. Okay. Now we need a connection. Here we can give this black one. This black one, we know it is negative, and this is cathode. Cathode is negative. So we need a connection from this negative part to this side. Okay. Since we have this vertical side have same connection, we have connected this negative. Now we need to give positive. From this part, I am giving to this here. Here it is positive. Positive is anode. Okay. We need to give this positive as red color. Okay, I am selecting this and giving it as red color so that no confusion occur. Now let us start simulation. Okay, when we start simulation, we can see that this our LED has been destroyed. What is the reason for the destroying of the LED is shown here. Here the current is 915 milliampere, while our this LED only it will carry only 20 milliampere. So that a large amount of current is passing to the LED, and this will destroy our LED. So we need to provide a resistance. We need to resist the current. So that we are introducing a component known as resistor. In order to know the resistance, what value of resistance we need to give. Okay, and for that we know that voltage is equal to V equal to IR. From that we can calculate resistance R equal to V by I. The voltage is 9 volt, and from that equation we will get we can take the resistance as 450 ohm. Okay, for connecting this we are placing it in the first we are placing it somewhere, then we are removing this thing, we are removing it. Okay, then we are placing this, we can place our resistance anywhere, that is any means either positive or negative, that is not an issue. Okay, we are now placing it in our positive part, anode part. Okay, now we are giving it as 450, resistance as 450 ohm. Here we can change the ohm, kilo ohm, milli ohm, like that. Now I am giving it as resistance as 450 ohm. Okay, I have given 450 ohm. Now we can see that this color coding has been changed. This will be dealt in the coming classes. Okay, now we have completed our circuit. Now let us do the start simulation. When we do the start simulation, we can see that our LED is not destroyed and it is blinking. Now when we stop the simulation, yeah, our LED is off. When we again do the start simulation, our LED is again on. So that in previous case, we know that when large amount of current came to our LED is broken or destroyed. Okay, now we have added a resistance. We have provided sufficient amount of resistance to the current flow. When we provide that, our LED will not be broken, and the limiting current, that means a small amount of current only, that is which is required for the LED only goes to the LED, so that our LED flows. In this manner, we can limit the current using a resistor. Okay, and you also need to study the formula, that is V equal to IR. From this equation, we can find the what resistance we have to choose. Okay, I hope you have understood the both the exercise I have said today. You need to work out this exercise using the Tinkercad. While first you are coming to a Tinkercad, you need to sign into the Tinkercad. You can either use a Google ID or an email ID for joining the Tinkercad. Once you make an account, you can easily create a projects. It is a completely free, and this website is easy to understand, and we can do many projects here.